Year 10 physics have done some really great work on things going round in circles, so circular motion or centripetal motion, and I just want to share some of it, some of the good points with you now. So this one I think is a really nice little project. It's talking about how satellites are used, the different types of satellites, and linking them to the different orbits, and they've made this lovely little model here which shows us the difference in a low polar orbit satellite, as you can see, which orbits around the poles and is much lower than a geostationary orbit which orbits around the equator and is much higher. And geostationary therefore have an orbital period of 24 hours, so they're always above the same point on Earth, so wherever we look at it we'll always find it. A low polar satellite has an orbit which is much closer to Earth, has a much lower time period, typically about an hour and 90 minutes, and can therefore, as the Earth spins in this direction, it was spinning in this direction, it can get to any point on Earth quite quickly by simply changing its speed. Now, to explain circular motion, Isaac Newton did this famous thought experiment, and it's called Newton's Cannon, and this is an absolutely lovely piece of work which is explaining Isaac Newton's ideas and how he managed to explain basically orbits, and this explanation is what our satellite's orbits understanding of that is based on, really. And she's given all the different scenarios. The basic thing is if you fire the cannonball in the right speed at the right height, it will be constantly falling to Earth, but the Earth will be constantly falling away from it, so therefore it will orbit, it will do a complete circle always at the same height, and it will hit us in the back of the head. It's a lovely piece of work. I love the analysis that she's gone into the details of all the 5 different scenarios that Newton described to explain that to people. Lovely. Some of them chose to do an experiment, and this is one example of an experiment write-up, really nicely presented. Now it's a really difficult experiment to keep factors the same, because the 3 factors that affect the orbit are mass, speed and radius. And actually if you change the radius, then it's really difficult to keep the speed the same. So what they've found here is it's quite a jumbled set of results, but they've talked about in their evaluation how because the radius was different, the speed increased, and that's why as the length of the string or the radius is increasing, they've found that force is increasing as well. And actually speed has a much larger effect on the centripetal force, so that's why it's kind of cancelling out that radius change. Anyway, really great efforts and lots of evaluative points, and that's all that really matters in that. Also, some students found out about the International Space Station, which is in orbit around our Earth. It's a polar orbit. It's a really nice thing, lots of information about orbits, the building of the ISS, how an orbit works. That's another way of saying the same kind of idea as Newton's cannon. You need to remember there's only one force involved in centripetal motion, and that's the centripetal force. And here, the ISS, this is the bit I really like here. The space station's ups and downs, because for all things orbiting Earth, they need to be at a certain height and a certain speed to maintain that orbit. So you can see over the years they've been changing the height of the ISS's orbit depending on how quickly they want it to go around the Earth. So that's some really interesting detail. And again, more interesting ways of explaining this, and other facts about how the ISS got up there in the first place in the space shuttle and on various other rockets.